So the for sum, given an array nums of integers, return an array of all the unique quadruplets such that nums A, nums B, nums C such that A, B, C follow in the range between 0 and n, and we want to make sure that A, B, C, D are distinct. And also another condition, the sum of all these three full numbers are equal to the target. And we will see that the length of the nums is between 1 and 200. And the nums, each element in the nums can be the negative, can also be the positive. Okay, so for this question, we can also use in the brute force way, we maybe use 3 for loops and try to find the difference between the target and the current sum of the three numbers to figure out the fourth number. But this will make the time complexity equals to n cube. We should reduce the time complexity. In this way, we can consider the two-pointer approach. That means we could set two numbers as a pivot number. Before we take the two-pointers approach, we can sort the nums, and we can make a list a variable named result to record our result that meets the condition, meets the requirement. So we begin to traverse over through the array. So for I in range nums, then we traverse through the j in range I plus 1 and the length of the nums and minus 1. Since we want to make sure that there might be condition that each element in the nums may be the same, so we have to do make some duplication here. For example, if I is bigger than 0 and nums I is also equal to the element before it, we should just continue the loop and do not do any operation. Otherwise, we could find the second pivot number j, and same here. If j is bigger than I plus 1 and nums j is equal to the element before it, we have to do some duplication. Then we just continue. And right now we could do our two pointers approach. Firstly, we should initialize our left pointer as j plus 1 and the right pointer as the length of the nums minus 1. So while the left pointer is smaller than the right pointer, we cannot make it equal there because they say that A, B, C, D are distinct. So and right now we have to make our judge if our current sum, which is equal to nums I plus nums j plus nums left plus nums right. Okay. If the current sum is equal to the target, then we find our number, find our results. Then so we just append our desired pairs into the result. That is nums I, nums j, nums left, nums right. And after we find a desired pair, we should move our pointers to find the other possible pairs. And if we find some duplicates, we have to remove them. So our left is smaller than the right, and the nums left is equal to the element before it. We need just to move the left pointer again. We do not need to do the deduplication for the right pointer here, because we know that the other the remaining value is determined by the value of nums I, nums j, and nums left. So we do not need to do the deduplication here. And there are two kind of situations. For the first thing is the current sum is smaller than the target. Then we should move our left pointer. We should just move right pointer to make our current sum smaller. And finally, we just need to return our results. Okay. So it is right now accepted. Let me submit it. Yeah, okay, it passes. So the time complexity for this question, it is n square. We make a sorting here. It is multiply log n, but I think n square is much larger. So the total time complexity is n square.